My name is Kent Wingert and I work with OPI Systems. This is a demonstration of the OPI Blue automated fan control system. If you have an OPI Blue system and you're looking to control your fans, it's a great resource for you. I'm going to walk you through the steps of setting your automated fan control set points. We'll use the example here on the screen to go through the different steps. If you have an OPI Blue system with fan control, you're going to have a weather station on the system. You're going to have Plenum sensors in each of the bins that you're controlling the fans for or wanting to control the fans for. Once all your system is set up and you've logged into it, you're going to go to the fan control page here. There's going to be a menu down the left-hand side. Just a simple click on the fan control portion of it. Any of the bins that you have set up for fan control are going to be displayed on the screen. We have a couple of options. We'll get into the manual side of it later, but right now I want to focus on the automation portion of it. So if we look at a specific bin that we're looking to have the fans come on based on conditions that we want to drive towards, all I'm going to end up doing is moving into the fan mode portion of that specified bin, clicking on the little gear icon that's there. A box will pop up. It'll allow us to make a choice whether we're going to be drying our grain. If we are, we're going to select natural air drying or NAD from the list. If we're beyond the drying stage and we're looking to move into aeration, which is creating a uniform temperature throughout the entire grain mass, then you're going to select the aeration portion. In this particular case, we're going to go through and we're going to select natural air drying. Once you've made that selection, a window pops up, and this is where you set in your set points. So in this example, what we're looking at doing is we're looking to drive towards our target moisture, and we want to make sure that we set our appropriate set points and operating window to be able to do that. That way the system with the fan control algorithms that we have does the work for you. It's smart enough to recognize when the conditions are right and the fan should be coming on, so you're only using your fans at the appropriate times to drive towards your optimum moisture target. So in this particular case, we have target EMC here, and EMC is your equilibrium moisture content, so that's what we want the grain to finish at. So when you go to sell it, depending on what you have, whether it's wheat, canola, corn, beans, rice, the targets are different for each individual crop, but we want to make sure that we reach that target so you're maximizing the moisture in the grain, maximizing the weight, and maximizing the money that you're going to get when you sell the grain. So we want to go ahead, and the user interface is meant to be extremely simple for you. It's just a simple slider situation here. So we go ahead and we select what target we want to do as far as our moisture goes. In this particular case, we've selected 12% moisture, and then below it, it says EMC, target EMC range. What that actually is that's creating an operating window. So you set your target, in this case, we set it at 12%. You have an operating window. So when conditions are within that window, that's when the fans are gonna come on and work towards your target. So what you want to do, especially early on, when you've just harvested your crop and you're putting the grain in the bins, is you want to make sure that your window is not too narrow, because if your window is too narrow, it limits the operating range that the fans are going to come on. So typically, when you put grain in the bins, you'll have a wider band that will allow for more fan time early on. And then as you get closer and closer to your target, you're going to narrow that operating range. So in this particular case here, we've got a 12% target, and we can move the sliders along here to create our window around our target. So here we've gone -2%, and on the high end, we've actually gone +2%. So we've got an EMC operating window with a target of 12. The low end of the window is 10, the high end is 14. When conditions are met on the EMC side with our ambient conditions anywhere between 10% and 14%, we've created conditions that are conducive for the fan to run and drive towards that target. We do the exact same thing here actually with our temperature target as well. So we go ahead and we create a target, and then we create the same type of operating window that we do with EMC. So in this particular case, we go ahead and we've got 15 degrees Celsius here. We do an upper and lower limit, which we go ahead and let's just say 2.5%, or sorry, 2.5 degrees I should say, on the upper and lower end around our target. So now we have a moisture target of 12% and a temperature target of 15 degrees Celsius. Once you've got that set, you just go ahead and save the changes that you've made. And then, like I said, the system with the algorithms that are in place is smart enough to know if the conditions are met with ambient conditions, it's conducive to run the fans. And the same thing when the fans are running, if the conditions fall outside those operating EMC and temperature target windows that you've created, the fans will shut off. So it's a great way to not have to think about and manually stop and start your fan and efficiently drive towards your targets, which are going to save you a lot of energy as well. Another thing I want to mention here as we scroll up, at the bottom of the pop-up window that comes in, there are advanced settings at the bottom, and I'll just give a little explanation on those advanced settings so you have an idea of what they mean. So if you need to change any of those, you can change them or make any of the changes appropriately. So when we look at it here, we have fan equalization time. Once the fan comes on, the plenum starts to measure the air that's going into the bin, and it needs time to equalize and come up to temperature. There's fan warming once the fan spools up. It heats the air through friction, it creates additional pressure. So the temperature of the air at the plenum is actually different than the ambient conditions outside the bin or temperatures outside the bin. So we want to measure there because that is the actual temperature of the air being measured. Ambient temperature plus the fan warming gets our actual temperature. So in this particular case, it's set at 300 seconds, so 5 minutes it takes for that to equalize and come up with an actual measurement once the fan warming is calculated. The next thing on there is actually minimum fan off time and then minimum fan on time. Those are fairly self-explanatory. We want to make sure that when conditions of the fan are in our target zone and it's operating, minimum fan on time is a set point that allows us to how long are the fans going to run before they turn off. The default is 300 seconds, so 5 minutes in this particular case, but it's user configurable. You can set it to whatever you want. The reason that's important, and the same thing with the minimum fan off time, is if our operating window or our conditions to operate or turn the fans off are right on that cusp of either the high or low end to where they're in or just out of the targets, you don't want your fans turning off and on, cycling off and on over and over. You want to make sure that your fan, if the conditions are just in and then they fall out, is going to run for a certain amount of time, whatever you set it to, or is going to stay off for a certain amount of time before it turns back on. So the fan's not cycling off and on, off and on. That's really hard on the equipment, and we want to make sure we don't abuse the equipment in any way. The next thing on there is actually fan warming value. And that's what we talked about earlier. When the fans do spool up, the friction it creates with the air and pushing the air in there creates a pressure change, and that actually warms the air going into the bin. So we want to make sure we measure that. We got maximum grain temperature set point. So when you're in aeration mode and you're specifically worried about getting a uniform temperature throughout the grain mass in the bin, if the temperature exceeds whatever maximum temperature threshold set point that you have here, regardless if the conditions are met to run the fan because you've actually exceeded that maximum set point, the system is smart enough to know that you either have a hotspot developing or a hotspot that has developed, and the fans are going to automatically turn on to cool that hotspot or warming grain down. So it's important that you have a reasonable set point in there as well. You don't want it set too high. If you've got it set too high, problems have already occurred. You want to make sure that you set it at a set point that's low enough that if you do get the fans coming on, they're mitigating a potential problem before it becomes a full-blown problem. Minimum air temperature and plenum pressure set point. So minimum air temperature is just the minimum temperature you will allow your fans to run at. It serves two purposes. It makes sure that if you don't have grain in the bins, the fans aren't going to run without grain being in the bins, because it's able to recognize temperatures of sensors on the cables that are within the bin, and when there's no grain in the bins, no sensors in the grain, it's not going to allow the fans to just kick on, which can cause damage to the bin itself or the aeration floor. The last thing is the minimum plenum pressure set point there. And what that does, we talked about plenum pressure and how we have a sensor in the plenum of the bin, and it's measuring temperature as the air is going in the bin. We also have a pressure sensor in that sensor down there, and that does two things. That gives us validation that when the system is actually calling for the fans to run, it gives a pressure reading in the system itself and provides us with validation that the system is calling for the fans and the fans actually have physically turned on. So it's just a validation process there, which is very important to make sure. We want to make sure that the system doesn't just call for the fans and we have no idea if the fans have actually turned on or not. So now that we've gone through the automated fan set points and we've gone through the advanced fan settings, if you've got any questions, you can always give us a call. There's also two options for you. You can look in the manual on page 71. It does get into the fan control settings. If you don't have the physical copy of the manual with you, there's always the option here within the user interface itself. Down in the bottom left-hand corner here, there is a link that allows you to bring up a soft copy of the manual itself. So use that as a reference. I hope you found this video helpful. If you've got any questions that weren't answered throughout the video, don't hesitate to give our support team a call. We're always available, 1-800-661-1055.